Hello there and then welcome to a brand new video. This is Hub Beyond Numbers where we learn maths the easy way. Now in this video we are on solving inequalities. We want to learn how to solve inequalities. In our previous video where we looked at the introduction of inequalities, we defined what they are and then we looked at the symbols we use in inequalities, and we also looked at how to represent inequalities on a number line. Prior to that, we looked at how to solve equations. And if you are not so conversant with solving equations, I would advise you visit the beginning of this playlist and understand that, because solving inequalities and then equations do have a lot in common, but then we'll be adding a little more to it in this session. So unlike equations that have the symbol just equal to, inequality on the other hand deals with the greater than, the less than, the greater than or equal to, and or the less than or equal to. These are the symbols we would have to deal with under inequalities. Now, to solve inequalities, you have to take note that you just have to solve it as an equation, right? And the most important thing you need to take care is anytime you multiply or divide by a negative number, then you would have to flip the inequality sign. What do I mean by that? So if you are going to divide or multiply by a negative number, then the greater than should become what? Less than. Less than then also becomes greater than. And then greater than or equal to would also become less than or equal to. And then finally, less than or equal to becomes greater than or equal to. So let's quickly look at what these mean. So in our first question here, it says if x plus 3 is less than 7, we have to solve for the value of x. So just as I said, we have to solve it as an equation. The same step we use, that is the same thing we are going to do. So we just want to make x the subject. We have our x, and then we are trying to move this 3 to the other side. So we maintain our equality symbol, that is less than. Then what do we have already here? We have the 7, and then the 3 moves to the other side so that it becomes a negative 3. In that case, you are going to get x is less than 7 minus 3 gives us what? A 4. So it simply means that any value that is less than 4 satisfies this inequality here. And sometimes you'll be asked to represent your solution on a number line. That was what we did the preceding video before this. So you can visit that and then get to know how to represent your solutions on a number line. Okay, so for this second question here, it says we have to find x if 3x plus 4 is less than 10. So we have 3x plus 4. If you do already understand the equation, then you can pause and then try solving so you test your understanding. So we have our 3x, then it is less than 10, and the 4 moves to the other side. By so doing, instead of the positive 4, it now becomes a negative 4. So that we have 3x is less than the 10 minus 4, which gives us a 6. Then at this point, we want to divide both sides by our 3, just as we did in the equations. So if we divide, this x here cancels out the x, and the x divides, sorry, the 3 divides our 6 to give us 2. Hence, our x is less than 2. And that is what the value, that is our solution to the inequality. Now, these two examples are very, very simple. Now, let's try those that would require us to change symbols. Okay, so over here we have to solve for 4 minus 2x is less than what? Less than or equal to 10. So with the same procedure, we are trying to what? Isolate our x. So we are just going to have our 2x is less than or equal to, since we want to move this 4 to the other side. So it's less than or equal to our 10. Then if the 4 moves to the other side, it becomes a negative 4. So if you want to continue, we have our negative 2x less than or equal to 10 minus 4. That gives us a 6. Now take note of what we are about to do here. So we have a negative 2x, which is less than or equal to 6. We are going to divide both sides by a negative 2. You see, negative 2. Now the thing here is, anytime we are going to divide by a negative, then that simply means we would have to flip our answer, our, what do you call it, the inequality symbol. You see, we are going to flip it so that instead of less than or equal to, it is then going to become what? Greater than or equal to. You see, as I flip here. Previously, it was what? Less than or equal to this here. But if you divide by a negative answer, this, if you divide by a negative number, then you always have to make sure that what? You flip your inequality sign, right? So in that case, it's no more less than or equal to, but then a greater than or equal to. You see, then we proceed from there. So as usual, this negative 2 cancels out the negative 2. We are left with x that is greater than or equal to a negative 3. Right? This here is our final answer. The most important thing we have done here is, instead of maintaining this symbol, we have flipped it. Why? Because we divided by a negative answer. You see, we divided by a negative number. So let's try one last question that also applies this principle, and then I'll give some trials. Okay, so in this last question here, we have 5 minus x all over 2 is greater than 3. So how do we go about it? 5 minus x all over 2 is greater than 3. So just as we did in an equation, anytime you have fractions involved, then make sure you multiply each and every term by the LCM of the denominators involved. This time around, our denominators are 2 and then 1. And the LCM of 2 and 1 is what? 2. So what we do is, we have 5 minus x all over 2, which is greater than 3. So we are going to multiply this here by the LCM, which is 2, and multiply this term also by the LCM. You see, and if you're able to do that, then this denominator cancels out this one, so that if it divides it 1, you are just going to left with 1 times 5 minus x. What do I mean by that? This is our 1 here multiplies this whole numerator, which is what? 5 minus x. So it's greater than our 2 times 3, which gives us a 6. So 1 times 5, we have our 5. Then 1 times x, we have our negative x is greater than 6. You see? Then we continue with our solution. So 5 minus x is greater than 6. And making x the subject simply means you are going to get a negative x greater than 6. Then the 5 moves all the way to the other side to become a negative 5. So minus 5. You have negative x, which is greater than a negative, which is greater than a 1. You see, we want x and not negative x. So what we are going to do is we will divide both sides by a negative 1. Or better still, you can multiply both sides by -1. You see? So what do I mean by that? This is times -1. Let me write the times well. So you have times -1 and then times -1. And remember, when we began, I said anytime you multiply or divide by a negative, then you are going to have to what? Flip your sign, your equality sign, your inequality sign, so that it no more becomes a greater than, but then a less than. So that our -1 times our x gives us an x. So you have x, which is then less than what? 1 times -1, which is -1. So this here becomes our solution. If you were to divide, you'd still get the same thing. So you can try that. Then let me know in the comment section if you had the same thing. Okay, so you have these questions here you can try just to test your understanding. I do hope this video was helpful. If there's any issue of concern, you can always let me know at the comment section. And if this is your first time, this is how Beyond Numbers will learn maths the easy way. You can always choose to subscribe anytime so that you'd receive updates on any video I release or post. So see you in our next session and stay safe. Bye.